Good afternoon, everyone. I'm Vijayendra Katiyar. I'm co-founder of Clean Start. With me, I have Tanush, who's a solution architect. I know we've got 10 minutes, so we'll do our best to explain what we do and do a short demo on our product. All right. Okay, can I get the slides, please? Sorry. Oh, you're connecting your laptop? Okay. Cybersecurity, I've been almost 2 decades in cybersecurity. Before this, starting this company, I was managing director for Trend Micro. I'm not sure if you heard the name. They are a big cybersecurity giant. I was running India and South operations for them. So while the slides comes up, okay, I'll just give you a quick context of what we're doing. So Clean Start, we are focusing on solving the software supply chain security issue. Today every business is a tech company, is a technology company, and the applications are equivalent to business. They are not just app enablers, right? So that's where the thought of how do we make these applications resilient or secure by design. Traditionally, what we have seen is almost 80-90% of the code which are used to build applications is from open source. And unfortunately, we inherit a lot of problem also from open source. Not that it is bad. You talk about a startup or large enterprise, that's how it is done.
It is displaying.
So what happens is, and this problem is known. I think most of you know this problem, right? There are vulnerabilities, issues which come along with when you pull a Docker image or a package or a library. And
It is present.
traditionally, what we have seen is use various tools in our CI/CD pipeline, typically SCA tools, which scan and identify the vulnerability, and then you kind of fix it.
You can.
So, all right, great. All right, so that's what I was talking about today. If you see the composition, almost 85 to 90% of the code is from open source, right? That's how applications are built. So if that is the case, and if it is a modern application, what we do as a developer or application development team is we pull these images from popular open source repositories like Docker Hub, GitHub. So this was a research we had done in Clean Start. So we pulled like 50 images, most popular ones. These images have a billion download. Now, not to a surprise, but then all of them had vulnerability. Today, also, if you go to Docker Hub, search for any image, you will 9 out of 10 times you will find an image having vulnerability. So all of them had at least high, medium, low, and 53% of them had a critical vulnerability. Now, where it becomes challenging is how these images are built, right? So there is a base, and you stack it up with different packages, dependencies, sub-dependencies. Now the vulnerabilities are in the base, in the packages, dependencies, and sub-dependencies. An image can have as many as 100 packages. In some cases, what we have seen is it goes up to 500, and that makes the job more challenging. So this is a quick example of PostgreSQL, very commonly used for database. Now, as you can see, uh, like this is a little dated, but then even if you go today to Docker and pull this image, you will find that there are so many vulnerabilities: critical, high, medium, and low. And where are the vulnerabilities, right? So it's in the packages, right, in the base. If I were to fix it, right, using a traditional approach, so what I will do is, yeah, this is another example of Cassandra, right? Very similar. So you can see there are so many vulnerabilities which are associated. So these are very popular images you use day in and day out for building applications. Now, how do I fix it? This problem is not new. We have been dealing with this problem for almost a decade. So how do we kind of are handling this? So a developer pulls this image from open source repositories, and they integrate with the CI/CD pipeline. And you've got as a part of DevSecOps practice, you use SCA tools, right? So there are a whole bunch of them which are available. So any of the commercials application which you use for scanning, so SCA tools which you use for scanning. So these tools, they are good in identifying what is the problem. So if you do a scan on these images, you will get a report like this. So it will tell you there are 300, 400 vulnerabilities, critical, high, medium, and low, right? Adding more context to it. Now, these tools will also help you understand that or give you a guideline of how to fix it, right? So, if anybody in the room, have you used any images, container images, Docker images build? And yeah, I'm sure. So, I'm sure, sir. So you must be using a tool like this, and then you scan, you get similar report. So what do we do? So these tools are telling us, okay, go here, download this, fix this, update this patch, upgrade the image, but they will not fix it. These tools will not fix it for you. The responsibility of fixing the issues lies with the developer. And that's where the challenge starts. So that's where we play a catch-up game. So there are about 300,000 plus vulnerabilities. 40,000 of them are critical. Every year we keep adding to this number, right? And you go to the biggest of the organizations, you will find they are dealing with thousands and thousands of vulnerabilities. So what happens is, since you're playing a catch-up game, you will fix critical and high, and you will accept medium and low as a risk. However, when these gets exploited, you are liable, right? You are answerable. This is something which you are accountable for. So let's take a step back. Now, if my 80-90% of the application is built from open source, right, and I inherit the problem, why do I have to bring it in my environment? Why don't I use something which is already fixed, right? That's the most logical way of looking at it. I have not created this issue, I have inherited this issue. So that's what we do with Clean Start. So Clean Start is a repository of clean, zero CVE hardened container images ready for production. So developers can do what they do best, is build applications rather than fixing issues, and leave that job to us, right? So a quick comparison of, like, if you pull an image from Docker, this is a Python image, you will get like hundreds of vulnerabilities. And look at the size of the image. Another interesting aspect, if you look at the size of the image, is 1.2 GB. And whereas the clean start image, we reduce the size of the image by up to 90%, which means resultant is faster pull time, better application performance. If you're running hundreds of containers on the cloud, you save on the cost. Now, the interesting part is these are distro-less images, which means we don't use Debian and Ubuntu as our base. For two things. One, these are vulnerable, and second, these are very heavy. The size of the base is around 200 MB, whereas our images are just about 10 MB, right? So I'll pass it on to Dhanush to explain how do we do that.
So Vijender just mentioned stating that we are going to use distro-less images. So so typical the Linux distribution, whatever we day in day out use, like your Ubuntu, RHEL, CentOS, they are generally the distro images. So these distro images, even in the Alpine, is also distro images, but it's a very lightweight distro images. Currently, everyone is using for your container images. So the major disadvantage of this distro images is it contains a lot of packages, and distro images are always meant to be run on your VMs and your mainframe servers. So what we have done is we have taken the compatibility of Ubuntu, which is the glibc compiler, and we have taken the advantage of Alpine base, which is a very lightweight base. We have made like a best of breed combination in terms of compatibility and size, and we have built our own distroless base called as clean start base, which is equivalent to your Alpine. So the advantage of our base is we don't have a shell, or don't have a kernels. We have only necessary runtime libraries to run your applications. Okay. So our base is generally of 8 MB max. And what we do is whenever you ask for an image, something like Python, Java, or Golang, we exactly know the SBOM or the packages has to go into to run your applications. Okay. So on a very quick, on a lighter note, why we want a ping package on your production? Why you want a duplicate package on your productions? So we make sure we remove all the unnecessary packages. While we install the packages, we make sure that all the packages are built from the trusted source, and also we make sure those packages are completely vulnerable free. On this basis, we will be able to provide you high performant, distroless, zero vulnerable Docker images. So if you see over here, so the same example, I'm using a open source privy scan, which talks about how many vulnerables you have in the Python latest, which is 1300 changes vulnerables. So if you compare with our public image of Python and our clean start image, so you'll be able to see currently our Python image doesn't have any vulnerabilities. It's absolutely zero vulnerabilities, both in terms of low and medium vulnerabilities also. So let's compare the size. So the clean start image is about 86 MB, and the Python public image is around 1.02 GB. Okay. So the reduction has happened at 90% stage. So when you are able to reduce the size of an image at 90%, and big organization or a small organization who are running thousands of hundreds of container in their EKS environment or any Docker environment, the pull time will be very faster, your data transfer will be very less, and your CPU consumption will be less. The number of Docker images you are running in your current environment, like for example, just hypothetically, if you are running like in a 16 vCPU server, if you are able to run 10 container images, we may help you to run up to 13 or 14 containers. So that's a small change. But when you are considering big numbers like thousands of containers, if you are able to bring our TCO to 10 or 15%, that's make a big change in terms of your profitability margin or like operational concepts. So these are the things where we will be able to other. So in terms of tracing, we will be able to trace back how you build the images. For example, if you ask us to rebuild the image from a previous version, we'll be able to trace back and build the exact image. In terms of compliance, all our images are FIPS compliance and STIX compliance. We make sure all the cryptographic necessary standards has to be maintained as part of our image. And also in terms of authentication, we make sure our images have been built from the authenticate source. So recently there was an npm is supply chain attack happened. The attack was very simple, where the npm registry was redirected to a fake or a untrusted website. So also in terms of verification, all our images are SIG stored. So we'll be able to verify, you will be able to get our metadata and verify our images, okay, where it has been built. And also in terms of SBOM, we give SBOM for all the images we deliver to our customers. So the customer exactly know what packages, what is the license type of the packages, and what's the versioning of the package.
So
And
just to add, Dhanush, sorry
sorry,
on that. See, it's about building trust and governance when you're building an application, because you don't know if you. So I say three things. If you don't know the source, if you don't know, if you're not confident about what are the artifacts, and if you can't commit that or make a confident statement that it is safe, it should not be used for building any application, right? So that's what we do. So we follow SALSA framework. I'll not get into too much of details. This is a good framework for software supply chain security. All our images are built on SALSA level 3 and level 4. And if you like, to give you more confidence, right, all our images are certified by Sigstore. So Sigstore is a third party like a digital notary or certifying authority, which certifies that the image is tamper proof and then the artifacts are original, right? So whatever claims you make, and you as a user can also verify the same. All right, so that's an example of commit ID which we have. Yeah, Dhanush, you
yeah.
can.
So basically, this is our metadata base. We will be able to track what is the exact source. And in terms of what we do is we will be keep on tracking the commits of the source. For example, OpenSSL package. We will be tracking the OpenSSL actual Git source. Whenever a commit happens, we make sure we rebuild the package. When we rebuild the package, automatically we rebuild the image. Whenever we rebuild the images, we make sure if any CVs has been identified, we will immediately rebatch and release to our customers. So for example, you can see the commit changes. So here you will be able to see the governance in terms of the cosign, whatever we do in terms of signature. So this is our salsa framework, how we will be able to see like what is the level of the framework. We generally follow salsa build level 3 and we are trying to get it done on build level 4 also. So these are the four unique proposition we bring into the system. So one is in terms of
So
vulnerability.
yeah, so four things I'll take. Yeah, Dhanush. Four things, four takeaways. We give you a clean zero CVE hardened container image, right? We debloat it. We remove whatever is unnecessary, like libraries, packages. As a resultant, you get a high performance image up to 90% smaller, faster runtime, and our images are also based on CIS benchmark. So, and since we work with a lot of customers, a lot of prospects in the US, FIPS compliant is mandatory. So we give you a FIPS compliant image. Huh? So we have a quick 1 minute demo we can run through quickly, and then so while the demo comes up, so what you will see is a repository, a clean start repository. We currently have around close to 500 container images, and slowly we will be touching about 1200 images, which are most popularly used across 90% of the universe. Um, yeah. Okay. Are we there? So this is something which you as a user you get when you subscribe to our images. You get the whole details, the SBOM, security advisory. Um,
We have just quickly made a quick demo video. So this is our portal where you will be able to log in. So, and once you see, you will be able to see our basically the portal which talks about how many images we have, how many VM images we have, and what is the vulnerability state, and how frequently we are patching the images, and what is the state. And also you'll be seeing when is the next vulnerable fix is coming if there is something which is already available. And also, if you quickly see, this is our portal where you can browse our images. For example, if you want to browse, go here, search Prometheus. So once you start browsing the image, so it will show Prometheus. and it also talks about like, okay, what is this image is it a FIPS version is available or a sticks hardened image is available. And if you go over here, it will give a quick summary of what is this image, what this image does. And also it talks about like what are the different variants of this image is available, and also talks about the tags, basically the versions, so which are the versions as part of it. And you can also see the SBOM. So whenever you see the image and you click on the SBOM, you will get a two types of downloadable SBOM, which is Cyclone DX and SPDX. And it talks like, which is the actual images or the packages as part of it. And if any vulnerabilities have been present, it will be able to show the vulnerabilities in the vulnerability section. And in the advisory, we will be able to tell you, okay, on the history of this image, what are the CVs has been reported, what are the fixes has been part of this images, and in terms of deliverables. And also we give a support portal to our customers. If the customer wants a different version of an image or a different, he is facing some challenges, he can raise a support ticket to us. So we will be able to address this back, and he will be able to track all the support issues over here. So it will be like a one stop for all your container and VM images, where you will be able to use zero vulnerable Docker images.
All right, that's it. So thank you everyone. I'm around. We have a booth, so if you have any questions, we'll be more than happy to answer. Thank you.